Hello everyone. In this video, we will be learning about conversion of isometric views to orthographic views. So isometric is nothing but the iso is constant, metric is the nothing but any of the value unit. Okay. So here you have a 3D objects. You have a 3D object. For this 3D object, you have to convert into orthographic views. So you have to convert minimum 2 views or 3 views. If you're converting 2 views, you need to draw the, for the 3D object, you have to draw the front view and top view. If you are making 2 views of an object, if the object is very simple, if the 3D object is very simple, you can understand easily, then you have to use the front view and top view are sufficient to draw the to represent the to show the 3D object into 2D, because your drawing sheet is of 2D. So if you want to show it as a front view and top view, if the object is simple object, then you can show it as the front view and top view. Suppose if the object is very complex and you need 3 views, minimum 3 views to draw the object, to represent the object, to understand the 3D object as a 2D, then you have to compulsory draw the front view, top view and side view. You have to draw the 3 views compulsory. So generally it will comes as a 10 marks question. Generally it will come for a 10 marks question. So for 10 marks questions, compulsory you have to draw the front view, top view and side view. Compulsory you have to draw the front view, top view, side view. So to convert a 3D object into orthographic views, you need to have a basic knowledge of the projection of points, projection of lines, projection of solids. You need to have the basic idea in order to convert a 3D object into either 2 views or 3 views. Okay, it depends whether, if the object is very simple, you can draw the front view and top view sufficient. If the object is complex, you have to draw the all the 3 views, and generally it will recommended, it will, you will get a question of 10 marks, so compulsory you have to draw the all the 3 views in order to get complete 10 marks in the exam. Okay, so I'll start with the introduction. So generally you have a 3D object, so I'll take a 3D object as a cube. Okay, so this cube is a 3D object. So generally we assume that this cube is placed in a glass box. This cube is placed in a glass box, and this object, this any 3D object is suspended by the threads. This 3D object is suspended by the threads, okay, into the glass. Okay, and what are the views you are seeing? So this is my example, this is my X or front view, this is my Y or side view. So compulsory you need to know what is meant by front view, top view and side view. If you are looking from here inside the glass object, you are seeing from the glass, this is your top view. Okay, and what are the reflections you are seeing on this one? What are the reflections you are seeing on this shape? Okay, okay, so we can see this reflection. The what are the observer, or who is the observer, he has to move from front view, side view and top view, then he can see the object as a 2D, he can see. Okay, so these things you have to represent here. So if you see here, you have to draw your XY line, this is called reference line, and then you have to draw your X1 Y1 line, then you have to draw your X1 Y1 line, and the object is, we are looking from this side, so from here we are looking the front view, so the object is projected here, the front view is projected here. Okay, and we are looking side view from this side, we are looking side view from this side, because the observer has to move from here to here and then he is seeing. Okay, so we are looking this y or side view, we are looking this X from right side, so it will be projected here on the X1 Y1, it is left side of the X1 Y1 line front view, and we are looking from the right, so from this point it will projected on the right side, it will project on the right side of the X1 Y1 line, and these two are in the same horizontal line. So this object should be in the same horizontal, and this is my side view. So in order to get the top view, you have to project these lines, and from here, either there are two methods to uh, from the side view how to draw the top view. There are two methods. Okay, so one method is, this is your object, and this is my front view. I have projected the vertical lines from the front view, and if I project the horizontal lines, I will get a side view. This I am explaining as a first angle projections. Okay, I'm explaining it as a first angle projection because in India we will be using only first angle projection. We won't be using the third angle projection. Third angle projection is used only in America and other countries. They will use the third angle projection, but in India follows first angle projection because it is easy to understand. Okay, so above XY line will be your front view, and right side of your XY line, X1 Y1 line, you will be having side view. And there are two methods. First method, which is easiest method, if you don't have any compass, then you can use this method, or else if your compass radius is longer enough and you are unable to draw the arc, then you can use this method. So this method is, you have to take an inclination of 45 degrees. You have to take a inclined line of 45 degrees, where you have the empty space between the y1 and y. You have to take an inclination of 45 degrees, then you have to project, draw the vertical line till this inclination line. So where it is touching, from there draw the horizontal line. Okay, and from here you have to project same thing till the 45 degrees inclination line, and then you have to project this one. Then this is your top view. You will be getting your top view like this. Or else if you have a compass and the distance are very small, then you can use this one. Okay, what you have to do is, you have to project till this. You have to project till x1 y1 xy line, reference line, you have to project. And then this is your radius. Take, this is your radius. Keep your compass pointer here, your pencil here, and draw the arc till here. So you'll get one arc. This is your r1, radius 1. And similarly you have to measure, this is your radius 2. This is your r2. Keep your compass pointer here, keep your pencil here, and then draw the arc. Because the radius is very small, you can use this one. And you must make sure that your compass doesn't have any error, then only you have to use this one. If your compass has any error, because in few cases what happens is, the compass pointer and pencil pointer should be of same height, then only you will get equal. Suppose you are keeping it as one at certain pencil, you are keeping certain higher the height or lower, then you will get some error. So whenever you are not sure of your compass has any error, then you can use this 45 degrees method, or else you have to use this arc method. So from here I have to project to xy line, and I have to take radius 1. This is the radius I have to take, and from here I have to cut till x1 y1 line, and from here you have to draw the horizontal line. And similarly for the next line, how many vertical lines are there, that many radius you have to take. So from this point you have to take the radius 2. It has to project till xy line. This is the keep your pointer center here, your pencil here, and again draw the arc. This arc should touch the x1 y1 line, and from this x1 y1 line draw the horizontal line, and this is your top view. Okay, so this is about the drawing projection conversion of isometric view to orthographic views. Okay, so you have a 3D object. That for the 3D object, you are looking at the front view. What is this one? You are looking at the side view. What is this one? You are looking at the top view. What is this one? You are seeing here. Similarly, in some cases, what they say that this is your front view. In some cases, in some problem, they say that this is your x direction, or this is your front view, they will be saying. And this is your side view, they will be saying. This is your y. In general, they don't represent y and z, they represent only x. If they represent x, the other side will be y. If they represent x here, this side is y. If they represent x here, this side is a y. Okay, so this is your y direction, which is nothing but the side view. Then how you have to draw is, this is your x, draw the xy line, and draw the x1 y1 line. Okay, then this is your front view. this is your front view. As per the problem, this is your front view. So you are looking from this side. I'm looking from this side. So this is will be my front view. This will be my front view. Okay. And I have to project the lines here. I don't know where it is. Then this is my side view. I'm looking from this side. I'm looking from right to left. So I'm looking from right to left. The projection will be on the left side. So I have to draw the horizontal line. I have to draw the horizontal line, and I have to draw the side view. Okay. And below I need to get the top view. So similarly, any one method you can use. Generally we prefer 45 degrees. It is better to take 45 degrees because sometimes you may have a problem that your compass has any wrong radius, and if you do any of the mistake, marks will be reduced. So make sure that take a 45 degrees line. This is the best method. If you are familiar with how to take the angles with the protractor, then this is the best method. We don't know how to take angles, and 45 is easy to measure because it is 90, exactly half you are making. So it is easy method to make it. Okay. You need your fix your drafter and make the projections. Make sure that your drafter doesn't have any errors. Draw the vertical lines and directly join. This is the best method. Okay. And this pencil you have to use H pencil only. Whenever you are making any projections, use the H pencil. It should be lighter, and the front view, top view, side view should be darker, and you have to use the HB pencil there. Okay. And because this is my front view, so I'm looking from this side. Front view will be right side of x1 y1 line, and this is my side view. So side view will be the left side of the x1 y1 line you'll be getting. And below top view you have to draw, say, take 45 degrees line from the center. Take 45 degrees line, project till here and project till here, and then from here draw the horizontal line. From here draw the horizontal line, and this is my top view. Okay. So this is a basic explanation. Okay. Then if I'm for the complete 3D objects, if I'm drawing the different object, then it is called orthographic view or multi-view. We can call anything in either orthographic view or multiple view. And we need to draw 3 faces, because for 10 marks they will be asking you have to compulsory draw the 3 faces: front view, top view, side view. You have to draw. No need of drawing behind view. After opposite of front will be behind, either left hand side view or right hand side view depending upon the problem. And no need to draw the bottom view. There are total 6 views. Out of 6 views you need to draw only 3 views depending upon the arrow direction, x direction. Okay. So this is an object. So example, this object is suspended in a glass box. Okay. And if the observer is seeing from this side, this is my front view. So this is my x direction, this is my y direction, this is my z direction. Okay. So if observer see looking, he can see this point, this complete square he can see, and he can see this line. That's it. He can see only 2 things: complete square and this rectangle he can see. So complete this one, and it is at a certain height. So this line also he can see, because this is not, both are not at the same height. There is some height. So he can see this rectangle and this rectangle he can see in the front view. Now he's seeing the from the top view. He can see this square. He can see from the top view. He can see this rectangle from the top view. He can see this rectangle from the top view. So this square he can see, this rectangle he can see, and this rectangle observer can see this rectangle. Now coming to side view, this shape he can see from the side view, and this is a some vertical height is there. So this shape the observer can see. So he can see this is a shape, he can see shape 1, and this is my shape 2. So both are the thing they can see by using this side view. Okay. And this I took from an American PPT. So it will show as a third angle projection. Okay. Then we are making the projections because it is a third angle projection. They use third angle projection. That's the reason top view will be above and front view is down, and beside front view it has side view. Generally in the first angle projection, we will see from the top. This is the top, and it will project here. Okay. So what are the shape we are seeing? It will project here. Because this is a numerical, they have used the third angle projection, but generally this top view same thing you will be getting here. Below it, you will be getting the top view. Okay, because you are seeing from the top, bottom you will get the shape. That's the same thing. Okay, so it is a little bit confusion in the third angle projection. So that's the reason in India we use only the first angle projection. Okay, yeah. So I hope everyone understood. So if you look at three-dimensional object, if you look at three-dimensional object, it has three dimension. This is called as the width. This is called as width. This is called as depth. This is called as depth, and this is called as height. Okay. So for the 3D object, you have total three things: width, depth, and height. Okay. Don't say that this is length, this is width, this is height. Or say that this is width, this is depth, and this is height. Okay. And if you see the top view, if you see the top view, you can see this depth is same, this depth is same, this depth is same, and this width is same. One more, you will be having the hidden lines. I will draw the hidden lines also. Okay, so this width is same, this width is same, and this width is same. And coming to the height, with respect to this height, this is the same height, this is the same height, this is the same height. So now you are seeing the top view. Now I'm seeing the top view. In the top view, what I can see is I can see this line. This line is nothing but the width, and I can see the depth. This is the depth. I can see the width. I can see the depth. So this is my top view. In the top view, I can see the depth and width. I can see in the top view. Okay. And coming to the front view, so we are assuming this is our front view. So in this front view, we can see the width. This width we can see, this height we can see, this width we can see, this height we can see. So front view has to be drawn like this: width, height, width, and height. Okay. And coming to the side view, in the side view I can see this is my depth. So here in the front view we are seeing the width and height in the front view. And coming to the side view, we are seeing the depth, height, depth, and height. So in the side view, we are seeing the height and depth, height, and depth. So this is our side view. Okay. So if you see here, there is no need of side view if it is simple object. There is no need of side view, it's simple object, because it is only two dimension. Because here we get the depth, here we get the width, here we get the height. Then no need of the height and depth. Okay. Generally, if a simple object you can understand this, then you have to draw only two views: top view and front view. And if it is a side view, if it is a very complex object, then you have to recommend that you have to use the side view. Okay, yeah, that's the case. Okay, yeah. So this is object, observe is for watching. This is my front view. So this is my front view. From the front view, I'm seeing the width, this height. This is the total height. From the total height, I'm seeing this height at this height, and again I'm seeing width, height, width, height, width, and height. This is my front view, whatever I'm seeing. And coming to the side view, I'm seeing this shape, this rectangle I'm seeing, and here I don't see this line. Then I'll be seeing this line and this line merged together in the side view. Then I can see this is my height, this is my depth, this is my height, this is my depth. These two lines merge together when you are looking from the side view. Okay. And if you're looking from the top view, you can see only two things: depth and width. So you can see this is your depth, this is your width, this is your depth, this is your width. You can see this one, and you can see this is your depth, this is your width, this is your depth, this is your width. And here one more thing is there. So it will be, you can't see in this orientation, but there is a line here. This is the depth you can see, this is the width you can see, this is the depth you can see, and this is the width you can see, because lines are overlapping. So I will draw as a first angle projection. So here I'm looking from this side, so this will be my first angle projection. So in the first angle projection, I can see this line, 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 and this line. You have to give your dimension, then draw the projections horizontally, then you can generate the side view. Okay, and this is your top view. Make the projections down, you can see the top view. Okay, and from here give a certain distance, then draw the top view. In the top view, this is distance is this one. Okay, so these are the distance. Know the depth, give the depth here, close. And this is a, you can see this is one rectangle, second rectangle, and third rectangle. You can see same thing, projections you can see. Okay, then draw the 45 degrees line, then project this line to here, project this line to here, then project this line vertically above, project this line vertically above. Then this is the two rectangles you can see. Okay, so this is my first rectangle, this is my second rectangle. So this is my first rectangle, I can see in the side view. This is my second rectangle, I am seeing in the side view. So these two, I can see these two here. Okay, so like this you have to draw. It has shown in the third angle position. So in the third angle position, top view will be above and front view will be below. So generally you have to draw, this is below, this is above, you have to draw. Okay, so this is your front view. Beside front view you have the side view, and above or generally in the same vertical line you will be having the top view. Okay, yeah, so this is about the, and one more explanation of glass box concept. This is a object. From this object I'm keeping the glass box. This box has total 4 views. One is front view, a rear view, top view, bottom view, right hand side view, and left hand side view. Okay, you have total 3 things. Okay, yeah, so I'm making, expanding the glass box. What are the views I'm seeing? I make those projections on the glass box, and then if you see here, this is the same thing. Either you can extend with respect to xy line till x1 y1 line, then take the radius and draw it, draw the vertical lines. So till extend till x1 y1 line, this is the radius, draw the arc and then extend. Okay, and with respect to x1 y1 line, this is the radius, draw the arc and draw the vertical line. Okay, with respect to x1 y1 line, extend till x1 y1 line, this is the radius, draw the arc and extend till here. Okay, you will be getting the shape like this. Okay, yeah, so this is about the explanation of the conversion of isometric view to orthographic views. Yeah, so if I remove all those dimensions, then this will be taking. So this is my, this will be my front view, this is my right hand side view, RHSV we call. This is my left hand side view, left hand side view. This is my rear view or back view we can call. This is our rear view, and this is my top view. In the first angle position, this will be my top view, and and this will be your bottom view. We call this as bottom view. So like this we will be making it. Okay, so I'll show you an example. So this is an example, this is a shape, and from this shape I'm looking, this is my front view. If I'm seeing this is my front view, so I have to highlight with the, in the exam you can take any of the different pens, you can say different color pens you can take, and you can highlight with the blue pen. You can highlight this because these are the things you can able to see in the front view. So this is the shape whatever you are seeing in the front view. So these are the shape you can see in the front view. Suppose if you are looking from the top view, you can highlight with the any of the red pen. You can highlight this shape, and this shape you can see it in the top view. Okay, and this you can highlight with any of the pencil or black pen, you can highlight with this one. Only this is the shape you can see with the another view. Okay.
Hello everyone, welcome to engineering drawing tutorials. So in this video also I would like to tell you how to analyze the front view, top view and side view for a given isometric view. Here also I didn't mention any dimensional values. Here I'll give you only the guidelines for analyzing the front view, side view and top view for a given solid body in isometric view. Okay, the first thing is I would like to tell you the front view. So the front view, already we know that when you are looking in a front view, the surfaces which will be normal to our view only we can see. Okay, so in this view whatever the colors I have given, the blue color, so these blue color surfaces will be normal to our front view direction. So in front view, we can see only these one, two, and three surfaces. Below this step, this surface is there with an L shape. Okay. So these three surfaces we can see in the front view. So that and in the top view, again we can see whatever the light green color I have given. Okay. In the top view means again the view will be normal to the top surface only. So whatever the top surfaces are there, those surfaces only we can see in the top view. So the color I have given as green color. So these green colored surface only we can see, okay, in the top view. And similarly in left side view we can see the yellow color surface. Okay, this yellow color surface only we can see in the left view because the view is normal to the side surface. Okay, so finally how will be the front view means here the combination of 1 2 3 surfaces, how it will be means like this 1 2 and 3 surface. Okay, and similarly the top view will be like this. Okay, one surface and two surface, one and two. So why this dashed line is given means here this step is there. Okay, the below there is no solid part here in this below this step. Okay, and its distance from this edge, this last edge is more than this edge. Automatically this corner point will be invisible in the top view. So the invisible lines already always we should represent with the hidden lines, that is the dashed line. Okay, now so this will not be visible in the top view, so that's why we need to represent with a dashed line in the top view. Okay, so one this shape on this rectangle you can see, so this is the rectangle here. Similarly in the left side view, this exact shape we can see in the left side view, so that left side view will be coming like this. Okay, now again why you have represented this dashed line means here the corner will be there for this rectangle. It is not fully covering the surface, so it is stopped up to particular distance only on this main surface. So this corner will be invisible when you are looking from left side. So when you are looking from right side here, it can be visible, we need to represent with the continuous line, but here it is not visible in the left side view, so that's why we have to represent with a hidden line.